Hello, I'm Yuko Akiyama from Fujitsu. I am the Vice President of Softwareization Technology Development Office, responsible for overseeing software product development. While 5G development is ongoing in various organizations, we Fujitsu have focused on utilizing OAI Node B. Today, I would like to talk about our achievement with OAI as well as our activities towards 5G. Fujitsu has been utilizing OAI since 2017 as a strategic member. The picture you were seeing was taken when Raymond came to our office in Japan last November. Since Fujitsu joined OAI, we have kept saying that code quality is important. Actually, we have implemented not only LTE basic features, but also introduced CI framework and tested OAI code with high-spec load tester that could generate massive traffic. Basically, all bugs and improvements found in these activities are already contributed to OAI community. Using this well-tested OAI code, we provided wireless bandwidth efficiency such as MIMO, domestic wireless specification support such as SXGP and BWA, and validation test using COTS UE. This slide shows our products. One is SXGP and the other is BWA system. In both systems, the eNodeB software is OAI. The function of the red boxes were originally developed by Fujitsu. SXGP is a proprietary TD-LTE-based communication method using 1.9 GHz frequency band. In Japan, SXGP is an unlicensed band, so it can be used without a radio license. It is used in connection with distributed antenna systems, DAS, which is easy to set up. Multiple antennas form a single cell, making it easy to deploy. This is for indoor use. BWS stands for Broadband Wireless Access. BWA uses the 2.5 GHz band. This needs a radio license, but it can cover a large area. 20 MHz bandwidth provides high throughput. We are contributing to the community the improvements we have made in these developing commercial products. The specifications of these systems are shown in this table. Since the BWS system uses MIMO, the 20 MHz bandwidth allows for 88 Mbps throughput on the downlink. The maximum number of UE per cell is 256. The confirmed throughput is close to the logical value. These are pictures of a field test at a power supply company in Japan. We installed BWA for outdoor and SXGP for indoor. The upper left is an aerial picture, and the setup place is around the white circle. Both SXGP and BWS systems have stable operation and no system down during the 4 weeks verification period. The BWS system provides connectivity at to downlink 7 Mbps and uplink 500 kbps over a distance of 1.7 km with good voice communication. The top and bottom figures on the right are visualization of the RSRP values for BWA and SXGP. SXGP provides good throughput anywhere in a 30 square meters room. The propagation characteristics are close to simulation results. We have been aiming for commercial use since the beginning. Even after OAI software had enough features and quality for private LTE use, it was difficult to get RRH. I think this issue can happen with 5G. Field-grade RRH cannot be easily connected to OAI now, and it won't be easy to get them, because most of them are for mobile operators. These do not match private use. Interoperable RRHs with an open front hall interface such as the OLAN are also useful for OAI. It is also necessary that it is easy to get a RRH which supports various radio frequencies, which is low price and easy to use. The other is about radio licenses. In Japan, there is only band 39 unlicensed band in LTE system. Both unlicensed and licensed bands require wireless equipment to be certified. Even if a mobile network system can be built with OAI, we won't be able to use it freely in the field unless we get a radio license. I think there are discussions in each country, but in the local 5G world, these systems need to be simplified. Now I'm talking about 5G. We have started OAI standalone development from September. We are mainly in charge of the upper layer, such as Energy AP RRC. These codes are implemented in December, and we hope to have one core in standalone configuration by March. The implementation of Energy AP in RRC has been completed, and one core sequence has been tested in an ITTI-based simulator. I think local 5G is an opportunity for industrial innovation. We would like to make it an opportunity not only for research, but also for product development. The SU development team is coming together in the community, and we would like to appreciate the OSA, Unicom, and 5G developers. And I hope that more developers will join us. Thank you.